Howdy! Day 12, Workshop Wasteland Tricks or Treats. And this one's probably a bit of a kind of called maybe rudimentary beginners type trick or treat, but I think it has a lot of value to anyone that's in the machining world or, working with metal. And we're going to talk about tapping a hole, which I know sounds like a really basic task, but it's not as simple as it sounds. So we, make believe we just machined this part, or we just have this hole that we need to drill and tap into something. And of course, first and foremost, you have to start with the correct size drill bit for the tap. Well, how do you come up with that? This is just one example of a little pocket chart. It has on the left side all the different size taps and threads, then 75, 70, and 60% thread. You gotta kind of use your judgment on what you need as far as how tight or how strong of a thread you need. The majority of the time, I use a 70% thread. And if I'm tapping something in aluminum, I usually go for a 75% thread. But most charts don't have that. They just have a single size. I'm going to show you an example of that now. So when you look at this chart, this is the Starrett inch and metric tap drill sizes and decimal equivalents. So say for example, you were trying to tap a 632, that's showing you to use a number 36 drill bit, which is fine. That's going to make a great thread. But what percentage thread is that? It doesn't really tell you anywhere what percentage thread you're looking at. So if we come back to this pocket chart, a 632, a number 36 drill is a 75% thread. Well, if you're drilling a hole in something difficult to thread, like say stainless steel, then maybe 75% thread's not the way you want to go. That's a pretty darn tight hole to try and get your tap into, especially if you're doing something small, a 256, a 440, something like that. So I just wanted to point it out. Lots of different charts available. Of course, you can always use Google. That's probably your best friend. Get on the internet and find the drill size that you need for a given size screw or bolt or a given size thread. On Little Machine Shop's website, they have a whole chart that you can print out for free. It's downloadable. I laminated it and it works really well. You have 75 and 50% threads. If you look, I'm not going to be able to show you on camera because you won't be able to see, but under 75% thread, it says aluminum, brass, and plastics. And then under 50% thread, it says steel, stainless steel, and iron. So this goes to show that even really by design, 75% thread is not going to work real great in something hard to tap like steel. So take that for what it's worth. I'm no expert when it comes to tapping and drilling. But what I do want to talk about a little bit is some of the different ways that you can hold a tap and what I have come up with that works really, really well for me. I'm sure we've all seen these T-handle type tap wrenches. Then we have, of course, a larger tap wrench like this, which is adjustable to hold different size taps. These work well, but on a small tap, that's a really great way to break your tap off because you get a lot of leverage with that. And then we also have different types of taps, plug taps, taper taps, bottoming taps. I'm not going to go deep dive into all of that, but what I wanted to show you is a couple of things that I've came up with that have worked really well for me. So the first thing that we have over here at the milling machine is one of these spring-loaded tap followers. It works really good, and I have no complaints with this, but on these type milling machines, these benchtop milling machines, the problem that you run into is the Z height, especially with a long drill chuck. I can put this in a collet and lose about 2.5 inches here, but the point being, you just got done drilling a hole, now it's time to tap. In theory, you would be able to put this in there, but let me move this table over. To get into our threaded hole, you can see we have over an inch of a problem here. This milling machine has a 2-inch riser block on it, so I have 2 inches more on the Z height than most people probably do. But the problem is, when this is pushed all the way up, I can't get my tap in. So this thing works great. It works really good in the drill press. It also works really good in the lathe. It's probably not the best move here on the milling machine. Obviously, you can run the tap by hand in the vise, and there's nothing wrong with that either. But the next problem that you run into with that is getting a nice square hole. So you drilled a square hole. It's still pretty easy to run the tap in at an angle and cut crappy threads, and then you kind of just scrapped what you were doing anyways. Probably have to go to the next size bigger if you're able to. But I was given a gift that I think is absolutely awesome. This is a tapping fixture. Let me turn it so you can see it better. And what this does is it has a drill chuck to put a tap in there. This raises up and down. You of course can spin it. This is adjustable for your height. And as you can see, I can gain a lot of distance here between my tap and the part. And there's nothing stopping me from extending this bar and making it even longer so I could make it even higher. So what's nice about this thing is that it's nice and square, right? The base is perpendicular to this, I guess we'll call it a spindle. So it taps nice square holes, which is great. I feel like you get a lot more fine control up here with this little T-handle, or even turning the chuck by hand. It's prevented me from breaking a lot of taps. I broke a lot, and now I haven't broken very many, so I think that's really good. I've also saw a guy on YouTube, I wish I could remember who it was, but for this arm on his tap fixture that he made, he used a connecting rod from a small engine, and then he used the small end of the connecting rod out here for his spindle, and then the larger side back here, he had a much larger, I guess let's call it a column, and bolted the connecting rod onto there, and he could still slide that up and down. And again, it worked really well, kept everything nice and square. So to most of you, this is nothing groundbreaking or revolutionary, but I just kind of wanted to show this thing off. I think it's a really cool tool. It's came in super handy for me. I've tapped a lot of really small holes. I've not broken a tap with this. I take that back. I broke a 632 tap in one of my YouTube videos, and it was just because I was being an idiot trying to force it through when I shouldn't have. But if you could end up with something like this or build something similar to this, I'm confident you would really like it. And I just thought I would show you one more quick little thing. So this is that spring-loaded tap follower. This end is a point. But if you take the back of this one off, and this is a Starrett brand if I remember correctly, if you take the back off, mine is an Allen screw, and you dump it out, the other end of this plunger is to accept a pointed tap. So this would be for one that has a hole in the back of the tap, and this would be for one that's a point on the back of the tap. So the point works great for the tap wrenches that I use most of the time because they are designed to have that point go into it, right? And then prevent this from moving around. But I just thought I would point that out. A lot of people don't know that you could take this apart. If you have the pointed taps, you'd probably want to switch this around and use the other side. So hopefully that helps somebody. I know, like I said, nothing revolutionary here to anyone who does machining on the daily basis, but overall I think it'll be helpful. Hopefully you enjoyed it. If you haven't subscribed, don't forget to do so, and we'll see you in the next video. Thanks for watching.